very good day, ladies and gentlemen, students. This is our second unit we're going to start today for our program. Our unit 2 is Introduction to Data Analysis. I'm sure you have gone through our first unit. Now in data analysis, there are learning outcome for this lesson. Number 1, we are going to talk about the concept of statistics. And number 2, we are going to talk about identify the concept of population and sampling. Number 3, concepts of variables, constructs and data. And finally, identify 4 types of measurement scale. Okay, our topic is Introduction to Data Analysis. We cannot run away from the word statistics. What is statistics? Statistics is a science that deals with collecting, organizing, summarizing, presenting a set of data. Now, statistics plays with numbers. Statistics plays with numbers, and we have to know making sense of numbers. This topic is how we make sense of numbers, and there are 2 types of statistics. Number 1, descriptive statistics. Number 2, inferential statistics. The fundamentals of this topic for today is on descriptive statistics, and the following subsection of this lesson and this topic, my other colleagues in another lesson will be having that. Number 1, descriptive statistics. What is descriptive statistics? Descriptive statistics comes from the word describe. The term descriptive comes from the word describe. As I told you, statistics is organizing, summarizing a set of data, making sense of the numbers. So what is descriptive come describe? How do we interpret the numbers? Here, descriptive as said describe of the numbers available. So in descriptive example, if I give you, we have a set of data we collected. How did the student perform in the class? We'll ask how many students got A's, B's and C's, we call it frequency count. Or how many students had how many top students in the class had 4 A's, 5 A's, 6 A's, we call frequencies. Second part, this is descriptive statistics. Number 2, percentage of students who got A's. First was frequencies, now was percentage. This is called descriptive statistics. The third one, the fundamental which we'll be discussing in this topic for the fundamental of this lesson is about the measure of central location. Measure of central location is the average scores of mean, mode and median. Okay, and the second one is inferential statistics. Inferential statistics come from the word infer. What are we inferring for? We are inferring from the sample to the population. That's where we'll be using inferential statistics. So now, as the fundamentals of this is population and sample. What is population? Population is the totality of items. Population is the totality of items. And sample is a subset of the population. Samples are the subset of the population. So that's why we have the word sampling. Sampling simply means how do we select the samples to represent the true population through the sampling techniques that you'll be used later. Will be described in a later chapter. So the word inferential statistics comes from infer from the sample to the population. So I hope you can understand this, and we're using about all the different types of tests which we'll be doing later. Okay, now let's go to the other part, explain the concepts of variables, constructs and data. Variables. A variable is a characteristic. It's a property of interest about each item in a population of sample. The word variables comes from the word varies, changes. So in other words, we have variables. Example I give you, something that changes. Temperature is a variable. Why is a variable? You can see the changing of temperature. Number 2, we can see gender. Gender is a variable because we have male or female. We see grades is a variable. You got grade A, grade B, grade C, grade D. So now we have different kind of variables. There are 2 kind of variables. We call it a quantitative variable and a qualitative variable. Quantitative variable simply means dealing with numbers. Qualitative variable simply deals with words. So in this case, quantitative variable simply means someone's height, weight, number of children. This is such a variable for quantitative numbers. Qualitative as is no deal with words. Example, qualitative, it will be like qualification, like a PhD, master's degree. This is called qualification. It's a qualitative. We have gender, we have male or female is qualitative, and this qualitative is synonymous with categorical variable. They have categories here. And there's special name for variables that have a dichotomous variable of a dichotomy state where the outcome is only 2. Example, gender is a dichotomous variable, the outcome is 2. Right, wrong is a dichotomous variable, that is outcome is 2. Urban and rural is a dichotomous variable, that's 2. So we have a special category of dichotomous variables. There are two types of quantitative data, we call it a quantitative variable, and we have discrete data and we have continuous data. Discrete take exact values, as we say, can be precisely measured. We have an instrument to precisely measure discrete data, which can be count a second. On the other hand, we have continuous data. Continuous data, it works on the scale we'll be talking about in the next one of intervals such as weight, height, and temperature. When we say weight and height and our age, we can't measure our age actually. We are 25 years old, 26 years old. The time evolved, and we were not sure what's our age after 30 seconds, 45 seconds. So in that case, weight, age, height we consider as continuous data. Okay, now the most fundamental things we're going to talk the final section of this class for today is the 4 types of measurement scale. There are 4 types of measurement scale. The first scale we call it nominal scale. The second one we call it ordinal scale. The third one is interval scale, and finally the fourth one we call ratio scale. Nominal comes from the word giving meaning to numbers. Nominal means name. Example of nominal data, like we classify our gender, male, female. We put 1 for male, 2 for female. We are giving numbers to represent something that can be quantified but cannot be operationalized with mathematics. Another example for nominal, what you call that? Classifying of those from rural and urban. We put 1 rural, 2 urban. We cannot say rural 1, we attach 1 is better than urban and so forth. Nominal. The second scale we call ordinal comes from the word order. Order the variables here, that means they are ordered in some dimension. Example, grades. We obtain grades A, B, C, D. We will attach 1 with A, 2 with B, 3 with C, and 4 with D. So now that 1, 2, 3, 4 carries the meaning of it being ordered. We can say 1 is higher than 2, we can say 2 is higher than 3, and 3 is higher than 4, but we can't say 1 is how many times more higher than 2, 3, and 4. So order, also another scale, another type of variable includes qualification. When we have qualification, 1 will attach with PhD, 2 with masters, 3 with degree, 4 with diploma, and so forth. Here again, the attachment of the numbers is being ordered. Another example of ordinal scale example will be Miss Universe. We have Miss Universe, then what you call Miss Universe? We call first runners-up, second runners-up, third runners-up, and fourth runners-up. Up to now, I have no idea why they are fourth runners-up. Why can't we just go gold, silver, and bronze? Another way, because ladies are very sensitive. That's besides the point. So that's ordinal. The third scale is interval scale. Here, the equality of interval between the scales. Example of interval scale, and the final one is ratio scale. The division of interval and ratio is the absolute value of 0. When the 0 makes sense, we call it interval. If it does not make sense, we call it ratio. For example, temperature. Again, the absolute value of 0. When the 0 makes sense, it becomes an interval scale. If the 0 does not make sense, it becomes a ratio scale. Example, the meaningful ratio scale of 0 if it's a ratio, and interval the 0 does not make sense. Temperature. Can we have temperature 0? Yes. Does it make sense? Yes. So it's interval scale. Number of children. Can we have 0? Yes. So number of children is a scale for interval scale. Now, for ratio, age. How old are you? Age will become a ratio scale. We have 0. We cannot say a person is 0 of age. If the 0 does not make sense, becomes ratio. Example, your weight. What's your weight? 0. 0 does not make sense, so becomes ratio. So the difference between interval and ratio is based on the absolute value of 0. So this is our lessons for today. I hope as a summary in this topic, we briefly discuss on the fundamentals of introduction to data analysis. We talk about briefly discuss concept of statistics, concepts of population and sampling, concepts of variables, constructs, data, and finally 4 types of measurement scale. I hope you enjoyed the lesson and have a nice day ahead. Bye bye.